Hello, my name is Keshwani. There's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 315. Please turn to it. Page number 315, and today's our lesson number 32. The very first problem on the page, problem number 46. In problem number 46, we are told that we have 10 booths. We are told that we have 10 booths. We are told that we have to sit 20 people. 20 people are to be seated. We are also told that each of these booths can accommodate. We are also told that each of these booths can accommodate 4 people, maximum of 4 people each booth. We are also told that there are 20 people that are seated, and we are told that no booth is empty. The question is, what is the greatest number of booths having 4 people? So we have a restaurant. In this restaurant there are 4 booths. Each booth can accommodate 4 people. A typical booth that you see there where 2 people sit on one side, 2 people sit the other side facing each other. So maximum that you can have in a booth is 4 people. The question is, we have 20 people in the restaurant right now. No booth is to be empty. There has to be at least one person on each of those booths. The question is, if that were the case, what's the maximum number of booths that we can have? What's the greatest number of booths that we can have having the maximum number of people on it? Which maximum number of people added, not we don't own them. With maximum number of people that a booth can accommodate is 4. So let's begin our story. Here we have 10 booths. We're going to draw our 10 booths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 booths. To start out with, keep your life simple. To start out with, put the maximum number on each booth. Maximum number on each booth is 4. 4, 4, 4, 4, 4. We are already up to 20. That's all we have. We only have 20 people in the restaurant right now. That's it. Now, if you were to do this way, if you were to put 4 on each of the booths, we'll end up having 5 booths that are completely empty. We are not allowed to have empty booths. We have to have at least one person on these booths. So let's put one person on each of these booths. 1, 1, 1, 1, 1. Well, that's 5 people. We have to take away 5 people from here. Okay, keep listening. Okay, it's very simple. So we have taken the 5 people from these 4 booths, and we have put one person on each of these 5 booths now. Question is, where are these 5 people going to come from? We can't take all the people from here, because we need 5 people, you understand? These are 4. If you were to take all 4 of these people and put them here, 1, 1, 1, 1, there will be nobody here. So the most that we can take from here is 3. Most we can take from here is 3. So we're going to take 3 from here, we're going to subtract 3 from here, and now we have 1 on this booth. We need 2 more people. So let's take 2 from this booth. And now we have 2 on this one. So what I'm going to do is erase this line so it doesn't confuse us. There. So we have taken 3 people from this booth. This booth originally had 4 people on it. We have asked 3 of those people to move to these 3 booths. 1, 2, 3. And then we go to the next booth and we ask 2 of those people to get up and move here, 1 and 1. Do you understand? That's it, we're done. So this is how they're sitting. We have 3 booths. We have 3 booths with 4 people on it. Then we have 1 booth with 2 people on it. And then we have 6 booths. 1, 2, 3, 4, 5, 6. 6 booths, 1 person each. That's it, we're done. And that's our 20 people. 4 times 3 is 12. We have 12 people here. We have 2 people there, and then 6 more. And those are 20 people. So the question was, what is the greatest number of booths having 4 people? The greatest number of booths having 4 people is 3 right here. The answer is 3. That's the most number of booths that we can have. That's the greatest number of booths we can have with 4 people on it, given the fact that there are only 20 people in the restaurant. That's all. That's it, we're done. Here's the tricky part. Just give me 1 second and I'll ask you the tricky part in a second. The question is, what would have been the answer? Now I'm giving you a new question. You understand? It's not in the book. We're making up our own question now. What would have been the answer if they had asked for not the greatest number of booths, but the least number of booths having 4 people, given the fact that we only have 20 people? Well, if there are 20 people and there are 10 booths, if you want the least number of booths, let's erase all of this thing so we don't get confused. We're done with this work. There are 3 booths with 4 people. We're done with this thing. Let's do the new problem. Well, that's very simple. There are 10 booths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We just put 2 on everybody. We just put 2, not on everybody, but rather every booth. So if you have 20 people, and if you put 2 people at each booth, then the number of booths having 4 people will be 0. So the question was asking, what's the least number of booths we can have? What's the least number of booths that we can have with 4 people on it? The answer is none. None. That's the smallest possible scenario. Then in this case, the answer would have been 0. The least would have been 0. The greatest we just found out is 3. Let's move on then. Next problem, number 47. In number 47, we are given a picture here, which I'm going to replicate, which I'm going to reproduce. The picture looks something like this. This side we are told is 4. We are dealing with the trapezoid. That looks something like this. There is this side, there is that side. We are told that this height is 3. We are told that this height is 3. And the question simply is, what is the area of the shaded region? Let's find out, shall we? What's the area of the shaded region? Well, the thing that we need to understand here is that we are told that from here to here is 8. I left that out. We are told that from here to here is 8, which is crucial because otherwise we can't solve it. If this entire distance is 8, and we are told that from here to here is 4, which means this distance from here to here, let's call it x, and this distance from here to here, which is y, that tells us, this implies that x plus y must be 4, because the whole thing is 8, and this distance is 4. This distance is 4, so then x plus y must be 4, because 4 minus 4 is 4. 8 minus 4 is 4. How do we find the area of a triangle? How do we find area of a triangle? Area of a triangle is 1/2 base times height. So here it is going to be, for this triangle, for the first triangle, it's going to be 1/2 base times height, which is 3, and for the second triangle it's going to be 1/2 base, which is y, times height, which is 3. 1/2. What do we notice? We notice that 1/2 times 3 is common in both of them. 1/2 times 3 is the common factor. We can take it out common. So it's 1/2 times 3 is the common factor. Once we take out the common factor, we are left with x from this part, from the first term. We are left with y from the second term. And of course we know x plus y is 4. That's it, we are done. So it's 1/2 times 3 times 4, or if you like, we can write this as 1/2 4 times 3. Now here 4 represents the sum of the two bases. It's still the same, 1/2 base times height, except here we're not dealing with a base, we're dealing with bases. This base and that base, the sum of those two bases is 4. That's all. 2 cancels out with the 4, and the answer is 6. The answer is 6, which is answer choice B. That's all there was. I'll see you tomorrow, okay? Bye now.